Hello again. This is Math 2232 coming to you from the College Edited page. And the title of this lecture is Integration by Parts. As always, please be an active learner as you watch these videos. By way of introduction, recall that the integral of e to the x dx is e to the x plus c, where this is a constant of integration. Again, this is an indefinite integral. So that's simple enough. Let's look at another problem. Suppose we had the indefinite integral of x e to the x squared dx. Well, to do this integral, we would make a substitution. We'd let u equal x squared, then du is 2x dx. If we were to solve for dx, we get dx is equal to du over 2x, and that's the same thing as saying this. So this integral becomes, we can pull the 1/2 out because dx has a 1/2 in it, and we get an integral homogeneous in u. And so that means that this is going to be equal to, there's the 1/2, the integral of e to the u is e to the u plus c, and then we reverse the substitution, so this is 1/2 e to the x squared plus c. Now again, that was simple enough because you remember how to do the substitution. Now, again, by the way, make sure you can do these substitutions quickly and easily, because from this point onward you're going to be doing some of these substitutions in your head, and so if you have to stop and write them down, it will slow you down quite a bit in doing the problems. Now let's look at an integral that we really wanted to do, our opening example of this section. So we want to look at the integral, the indefinite integral of x e to the 6x dx. Now if we had an x by itself, or e to the 6x by itself, we could do this integral easily enough. Likewise, if the integrand was x e to the 6x squared, we could do the integral with a substitution. However, here, unfortunately, neither of these are options, so we have to do something different, and that's going to be integration by parts. So we're going to derive a formula for integration by parts, and here's how we begin. So let's start with the product rule from Calc 1. So this is the derivative of the product fg. So fg whole prime is equal to f prime g plus fg prime. Now if we integrate both sides of this, and we're going to let the constant just be the same on each side, and it's going to be 0. So the integral of this side, fg whole prime dx, is equal to the integral of the sum of these integrals. Now when we integrate the derivative, we just get fg, and so this in fact is, and then we do the integral of the sum is the sum of the integrals. So this expression right here is in fact a key in our derivation. So f times g is equal to the integral of f prime g dx plus the integral of f g prime dx. And if I were to solve for this term right here, the integral of f g prime dx, I would get this. I would move this to the other side, and so what I would get, actually I would move this to the other side, and so I will get the integral of f g prime dx is equal to f g minus the integral of f prime times g dx. So this is actually the formula for integration by parts, but we often don't write it this way. We'll often write this in terms of u and v. And so we let u be f of x, and then du is going to be f prime of x dx, and we let v, a different variable than u, be g of x, and dv is g prime of x. So you see, you should note that what you have here is the integral of u, and then this is dv. And so when we make these substitutions into this formula, this is the equation that most people think of when they're thinking about integration by parts. And so said in this way, the indefinite integral of u dv is equal to uv minus the integral of v du. You want to memorize this formula. Now, to use this formula, we have to figure out what is u and what is dv. We will compute then du and v, and then use the formula that we have right here. Now, note that computing v is very easy. V is going to be the integral of dv. Now, one of the more complicated things about using integration by parts, and some students struggle with that, is that you need to be able to correctly identify both the u and the dv. It won't always be clear what the choices are, and we will on occasion make the wrong choice, but you crash and burn and go back to the beginning. And there's no thing better than having experience with this, so you learn from your mistakes. This is not something to worry about. If you make the wrong choice, magic won't happen. Things will get worse instead of better, and you can go back and correct your choice. This does, however, lead to the obvious question of how do we know if we make the correct choice for them? Well, the answer is pretty simple. If we make the correct choice, after using the integration by parts formula, the new integral, the one on the right of the formula, is one we can actually integrate. That is, magic happens. Now, some high-level guidance I will give you, though, and this is not in the set of notes, so I've added it. The integral, the function you pick for u, generally gets simpler when differentiated, and dv must be something you know how to integrate. So if you have those two things, you got a pretty good chance of making the right choice. So let's look at the integral that we talked about above that we really wanted to do to open this discussion. Okay, so you're supposed to evaluate the following integral. Obviously, you want to use integration by parts. So find the indefinite integral of x e to the 6x dx. You know what to do. Let's see how you did. Okay, well, you're going to let u equal x, because then du is dx, and dv is going to be everything else. You see, u dv is everything. So if I pick this to be x, this must be dv. And so this is 6 e to the 6x dx. And when we integrate this, and you do integrate it in your head, you're going to get 1/6 e to the 6x. You can always take the constant to be 0 in this case. And what I do is I guess and then check to make sure it works. So if I were to take the derivative of this, I should get, or the differential of this, I should get this, and if you check, you do. So that means this is a correct thing. So now we'll use our integration by parts formula. So the integral of u dv is equal to u times v. That is x times 1/6 e to the 6x minus the integral of v, which is this, du. Well, this just stands alone, but this now is an integral I can evaluate. Now you have to use substitution again for this, and you should follow this calculation. But what you get is this is going to be minus 1 over 36 e to the 6x. And now I do include my constant of integration, and if there were other constants of integration, they all get mapped into the same one. And so this is the answer to the problem. And since we could do the problem we knew we did, magic happened with all our substitutions, so we did make a good choice for u and dv. Now let's look at integration by parts for a definite integral. Everything we've talked about so far was indefinite integrals. And so the formula becomes this. The definite integral from a to b of u dv is equal to uv evaluated at a and b minus the definite integral from a to b of v du. Okay, so that's the formula we're going to be doing, and we'll go from there. And let's look at another example. Evaluate this integral from -1 to 2 of x 6x dx. You know what to do. Let's see how you did. Well, we actually already did the indefinite integral, so we really just have to evaluate the indefinite integral at 2 and -1. Be careful when you do this because of the minus signs. And you see you put 2 in, you get this minus, and it's minus the whole of this antiderivative evaluated at -1. So this is the way the SIGNs work. You must be careful with your signs on this. If you do the calculation in correct terms, you get the exact answer is 11 over 36 e to the 12 plus 7 over 36 e to the -6. Now this is significant. This is the exact answer, and this is what I would expect you to share with me on an assessment, because this is the exact answer. Don't plug this into a calculator because this is the exact answer. We also can have trig functions involved. So here is another problem for you to consider. Evaluate the following integral, the indefinite integral of 3t plus 5 times cosine of t over 4 dt. You know what to do. We'll see how you do in the next lecture. But now, more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now, more than ever, take care of yourself and of each other. We're all in this together. God bless you all until you watch the continuation of this lecture.